let's read the question what we have today. So today we have given question is 1162. So each question is as far from the land as possible. The question, let's read the question. Question 7, we have given a grid n cross n containing only values 0 and 1, which represents 0 represents water and 1 represents lands. What we have to do, we have to find the water cell and such that this nearest land is maximized. Okay, nearest land should be maximized and we have to return that distance. If no land or water is there, return -1. So now it is saying the distance used in this problem is Manhattan distance. It means Manhattan distance, you can say, in which the distance two cells we have given x0 y0 x1 y1. So the distance would be x minus x0 minus x1 and plus y minus another of cells, right? Means 2 points we have given. This is point P1 and this is point P2. So if you find the distance between these two, so we used to calculate in the coordinate like this one only, right? X1 minus x0, and we will use to do the plus y1 minus y0, right? So this is it called the distance, right? And we will get this distance, and this is the distance, right? So what we have to do, we have to find the distance, right? Uh, we have to find the distance water cells that its distance from the nearest land is maximized. Okay, so let's take this example, right? So we have given this example in which we have given I'll represent in water and land. So first one is given, that is what this is our land, and another is given water, another what we have land. Next we have water. Next we have given land, water, land. Okay, so in this way we have given a grid. So let me represent this. Okay, so this is we have given, right? So what we have to do, let me give me a minute. Okay, so as you can see, I think if we'll take this one, right, this, if we'll take this one and we'll check with the this one, right, so we can get the distance, more distance we will get. We'll take this one, so we'll get the more distance, right? How? Let's suppose we are taking let me go back and take the eraser. Okay, so what we will do, let's suppose we are taking these two. Okay, I'm taking this one and this one. Okay, so coordinate for this one is, this is let's suppose we have a x is going and here y is going, right? This is x and this is y, correct? So what we will do, x is the first what we have x 0 and y 0, and its coordinate we have given, and both are at what, 0 0. First coordinate we have given. So first this is our land, at the land, and second we have water. At the water what we have here is we'll take next one, right? Means this one I am talking about, this one. So it will become what, it is x0 only, but y1 is this one, let's suppose. So this will we can represent at 0 1. Okay, so if we'll find the distance, what will come, 0 minus 0 and plus 1 minus 0, suppose. So it will come what, 0 minus 0, sorry, 0 minus 0, it will come 0 plus 1, and that is 1. The distance between this cell and this cell is 1, right? Similarly, if we'll find from here to here, we'll get distance between both is 2, right? So if we'll find the distance between these two, we'll get 1. But when we'll come to here, this point, right? So what will happen? Let's suppose we are taking this one. Let me clean this one so you will understand. Okay, give me 1 minute. Sorry, I will represent again, don't worry. Okay, so what we have taken, now we'll take this one and this one, correct? This one and this one. So what will happen, previously the L was at what position, we have 0 and 0, right? So if we'll take W position, it is what we have, 1 comma 1, right? If we'll find the distance, what we will get, and 0 minus 1 plus 0 minus 1, and that is 1 plus 1, and we will get the distance 2, right? So this is the output we are getting here. Okay, so maximum distance we can find is this, right? Or if you try to find any other distance, you can try this one. Okay, so if you try to find the distance, right, the maximum distance you have to find from all these, you have to do by one all this, right? And you have to find this one, right? Let's suppose we have what, now we have given the example 2, this one. Okay, so in the example 2, what we have given, at x0 and y0 means 0 0, what we have given, we have given land, right? But the all everything is at this position is what we have, water only. So we'll check with the all distance, we'll come to the final one, this one, and this is what we have, means this is our x0 x2 x2 we have, and y2 we have, right, at this position. So we are checking this one and the last one, right? So this is what we have 2 comma 2, correct? 2 comma 2 we have, and this is our water. So if we'll do the distance, what we will get, 2 minus O plus 2 minus O, and that is our 4, and that we are getting here as a 4 as a output, correct? Means total distance you have to find, right? So which one is the maximum? I'm taking just this maximum, right? And everything is minimum if you'll try to find. So each time you have to find the maximum distance between overall. Okay, means what you have to check one by one, all to its never cells. Like first we will go to the this way, then we will go to this way, right? We will move, we will check, right? Means both directions you have to check with all the cells. Means total cells we have given what, if you give me 1 minute. So let's suppose what we have given, if we have given total let's suppose what we have given, let's suppose I have we have given n matrix, right? N size, what the total size of the element will be, n into n elements will be there, right? Total cells will be there. So in these cells, water is what, 0, and 1 is sorry, land is 1, correct? So land cells and water cells is there, right? So only 1 0 and 1 cells is there. So what we have to do, we have to find the maximum distance of any 0, right? Means any 0 to 1, between 0 to 1, and this should be its nearest, right? Its nearest one we have to take, and then we have to find. So nearest one will take, and will take the water, and will try to find the maximum distance. So in other word, we can say for every cell that we have 0, right? With cell 0 value, means we are talking about water, we need to find nearest one using the Mantham distance actually, right? We'll see that. And the that actually you are going to find the coordinate, means coordinate system, right? You will if you have the basic understanding of coordinate, right? Obviously you are engineer, you will have. So what we have to do to find the distance with every one, right? What we have to do, we have to take the minimum distance. To find the distance for every one, we have to find the maximum. In the matrix, we have to find take the minimum distance, right? For every distance, right? So the distance, the maximum, you can say the maximum of the all these minimum will be our answer, right? What I'm saying, like what we will do, we'll try to find we can try the brute force approach, and that would be that we can iterate over all the zeros, right? So for each zero, what we will do, for each zero, first we'll go, let's suppose first we'll go this one, then this one, then this one, and then this one, then this one, right? We will apply for all these zero, right? And for each zero, we will find the distance for every one, as we can see, right? For this one we'll check, we will this one, for this one, and this one we'll check. For we for each zero we will find the distance for every one in the matrix, right? And we'll take that minimum distance, we'll take the minimum distance, and we'll do what, we'll say the maximum of the all these minimum will be our answer. right? Got it? So the answer, sorry, for our approach should be what is not efficient as a worst case, but you can say if it can be what if there is n square element is there, right? So we can say in the worst case can be what n by 2 you have to check, or you can say for n by 2 zeros are there, means half of the element is what you have 0, or n by 2 n square is what that can be possible here by 2 is maybe for 1. So either half of element will be 0 or 1, right? So this is our worst case will be there, right? So what we have to do, we have to check all the elements. This is the problem we have, right? So this is the worst case we will get, but the time complexity is very tough, right? That you can see if n square element will be there and n square element will be there, what? So total what we have to do, n to the 4 o n square time complexity will be there, right? So which is not fast enough, but we'll take we will take the n and we'll move up to that element, right? So what we will do, let's see what constant we have given. So constant we have given is n equal to grid, and n of grid is its length, correct? We'll have given. So means total n cross n we have given, and n should be less than between 1 to 100, right? So that is we can say the time complexity that we will get on square, right? That we will get on square, but sorry, on to the power 4 that we will get in the worst case. But uh, yeah, that is what worst case, right? But it is not enough fast, you can say. But we have to consider n maximum what n is should be less than equal to up to you can say 100 only, right? Yeah. Now if we'll talk about the position is we have given in the constant either 0 or 1, no other element will be there, and this question has been asked in Amazon, Google and Microsoft as well. Okay, so this is you can say important questions we have. Okay, so what similar questions we have given, the shortest distance from all the building, right? And if you already work with the k highest rank item with the price range, that question is similar, right? So these two questions we have given for the similar questions. If you'll try this question, you can try another these two questions. Okay, so I'll try to create on the video on these two. So please ping me in the comment box, I'll create that video. Next, what we have given here, can you think of this problem in the backward way? This is our hint we have given. So backward way we will try to do, right? And another hint is saying imagine expanding onward from the each cells, and what kind of search does that, right? Next we have given hint is use BFS starting from all the cells in the same way, means we have to try to breadth first search, and then what do you reach the furthest water cells, right? Right, we'll try these things and we will understand. Okay, so this implementation saying that we will try our breadth first search, right? And you can try also after completing the breadth first search, you can try the dynamic, right? A dynamic approach, and you can optimize our you can say complexity, right? And if not, then you can try the space optimization also, right? So we'll see the approaches here, and let's start doing this one. Okay, now if we'll talk about this one, right? Approach, let's suppose what we have given breadth first search. Okay, so in the breadth first search, what we will do, instead of iterating 0, what we will try to find the nearest one to each, and then if we will try to find, we will try to iterate one, right? Then what we will do, we can think of doing the brute force only, right? But in the opposite direction we'll go each time. So for each one, what we will do, we'll try to iterate over 1s, and for all one we will try to find on the zeros, and then we'll store the minimum distance for each zeros. But but this will not want you stop to help, right? And you cannot get our every pairs of 0 and 1, right? So what we will do, first let's suppose we need to we need to find the shortest distance here for all zeros, right? So we will do the breadth first search traversal, and it's also a kind of traversal which is used for the shortest path finding, and generally we use it to find the shortest distance from the distance from the single source, you can say, or node, you can say. But we have multiple 1s, right? So what we will do, we will go what we will do, so we will use multiple source breadth for search, you can say, right? So the reason we use BFS from 1s or not 0s is BFS from 0s will need the execute individually from each 0 to find its nearest one, and hence we will end up with exploring every zeros pair, right? So if we'll take, let's suppose what we have given here, let's suppose we have given some 1, then we have given 0, 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 right? So if we have 1, we can iterate any of this direction, right? So essentially what we will understand, we'll try to find our ones, right? And at each step we will iterate all these 4 directions, right, as I told you. So either we'll go up, left, right, and down for each one, right? So this moment we will reach at a water cells 0, right? We will reach it at the water cells, and we can say that the number of steps we have taken so far is minimum distance of this water cells. So from any land cells in the matrix, right? If we have the matrix, let's suppose I'll take the big one, this one. Let's suppose we have here 1 we have given, here 1 we have given, and I'll take one more 1 here and one more 1 here. Okay, let's make this like this. Okay, and rest of we have 0 0 0 0 0 0 0 0 0 0 0. Okay, so we have 1 here, we have 1 here, we have 1 here, we have 1 here. Okay, so these will go give me 1 minute, right? So what we will do, we can go this direction or we can go this direction. These can go all direction, you can say. This can go all direction. This can go this direction, right? He can go up, he can go left, or he can go down, right? And he can go right and left both, and up also. Okay, so total, as you can see here, what we have given, we will start with all 1s at each step, and we will iterate all its we will iterate in all 4 direction, up, left, right, down, and for each one, right? So the moment we reach at a water cells 0, we can say that the number of steps we taken so far is the minimum distance for all the water cells for the line in the water, and this way we will iterate over the whole matrix until all cells are covered. So number of steps we would need to cover the last cell, last water cells, you can say, is the maximum distance we need to find, right? So if in this way, if we'll try to find, right, so what we will do, we will try to find the distance, right? Distance between these two. So between distance between these two is what we have here. We will get, obviously we will get 1 from the next. If we'll try to find from here to here, right, what we will get 2, 3, and if we reach to here we'll get 4, right? Similarly, what we have to do, each time we have to find the distance, right? And then we'll calculate, we'll try to find this one. Okay, so now what we will do, let's understand this representation, right, so that you can understand easily. So initially we have given this matrix, right, and all ones we can iterate to in each directions, right? Left, up, down, right, we can go for all ones. And this moment what we will have, if the water cells is 0, we can say that the number of steps we have taken so far is the minimum distance, right? Now we will iterate over the whole matrix cells that cells and will cover, right? So the number of steps we will need to cover the last water cells is the maximum distance we need to find. So initially, if we will take the distance between these 0, right? So initially we have distance 0. So what will happen, we will come to here and we'll check it nearest cell. If nearest cell is there, so what we will do, if that is not visited, so we will make it visited like this, right? And then we will move. So now this one is visited, but now we will make this as a 1, right? Because we have covered with the distance what, 1. So after completing this distance 1, we will reach to here, right? So if you'll see that this is become what, a 1 0, this visited is 1, and now the second one, the water become 1. So now the 0 and 0 is remaining, right? So if we'll take one more distance, right, both side, right, so these two cells from this side and this side, right, it become 0 0 will become 1. So similarly we will get this matrix in the right. So in the last, if we'll take in both side, we will take, but this cell is not going to covered, and similarly we have here in the figure, right? So for the distance 0, distance 1 and distance 2, right? Once the distance 2 is covered, then all the cells are now visited, and no, there is no left non-visiting cell is there. So now you can see that once we reach there, we will have all the distance till the distance 3, we will have all the visited cells as here, right? So once you have the visited cells, you can find the distance, right? You will have the maximum distance you can find, right? So you now you have this graph we have, and from here what we will do, we'll take the two position, and from the two position from here to here, you can count the distance, right? Like this. Okay. So what we will do, first we will try to iterate over the matrix, and we will insert all the land cell coordinate into the queue, right, for the BFS. And then we should do what, we will perform the traversal of the element in the queue, and once that its traversal, we will make it visited. And after the level is traversed, right, the inner loop will complete. Then what we will do, we'll increment the variable in the distance, and we'll repeat until the queue becomes empty. Once this is done, then we will return the distance, and we'll check if it is equal to 0. It means there was no water, and the BFS has been finished now. So first step we will take that, will return -1, right, if we will finish this one, right? So when the matrix doesn't have any land, then this loop uh, will not start and at all, and when we say that, hence distance will be will have its initial value is -1, correct? If we will find that, then we will return. So better what we will do, we'll go to the browser and we'll implement this one. Okay, browser. Okay, so we have given what, we have given grid, and we have given what, grid, and we have to find the distance, right, max distance. So what we will do, we'll try to take one visited, so that we will that we have seen, right, that we will make a visited node cells, right, and that we will store those things, right? So let's create one array of the same size of the grid, right, and we will mark it visited, and we'll say grid. Okay, visited grid cells you can say. And this is our we'll take new int, and this is our first we will take grid dot length, and let me zoom a little bit. Okay, grid length, and then another we will take what, grid at the position what we have, initial value 0 dot length. Okay, we have taken grid length, and then grid at 0 at length, right, x and y coordinate, or each cells, row and column you can say. Now we have the visited grid, right? We will store all its mark cells that we have, we land once we have, we will mark the water cells once the land is visited, right, as previously we have done on the graph, right? Now for all direction we will take one directions. What we will take, we'll take here only, let's suppose we will take int, and we will have our all directions, right, and we'll say this is our direction. Give me 1 minute. Battery was down. Okay, so what we will do, we will have our direction, and this direction will take what, our new int will say, and we'll initialize here only. How we'll do that, we'll take two variables here at each position, and we'll store here. Okay, so at each position, what we will do, we will pass -1 0. Similarly we'll pass, we can take a 0 0, right, from the left up and right. Yeah, we'll take 1 0, and then we can take similarly we'll take 0 comma -1 and 0 comma 1. Okay, so from this is our x and y, right? So x is -1 means we are going to left side. If x is 1 means we are going right side. If -1 is y is -1, we are going down, and if 1 is there means we are going up in the direction. Okay, so all directions we have. Now if we have this directions, right, we can give the directions, right? If we have these directions, right, if we have these directions, we will go up, down, left and right, correct? Right, this is for we can say this is for left, right, up, down and up. Okay, all directions we have. Now what we will do here, we will do now we have the visitor we have taken, right? So we will take the BFS, right? So for the BFS, what we should do, we will put the land into the queue, right? So what we'll do here, we should take one queue. Let's see, I'm taking queue here, and this is our in the pair we should take a pair class, right? And the pair class will take two pairs integer. This is in Java 9 integer, and then we'll take integer, so we can store into our this one. Okay, so we'll take our this is our, we'll say queue, and this will take our what, new linked list. I think you knows already this one. So once our queue is done, right, we have to store all the cells into it, right? So for that, what we should do, we'll take the for loop. We'll start from int I equal to 0, and then we'll go I should be less than grid dot length, and then we'll go to I plus plus, right? This loop is done. Now what we should do, for all I, we have to go with all j, so that this is our, we will travel to all the grid value, right? Now for all I, all row, we have to go j. Row and column you can also give this one, right? So we'll understand. Now we'll go to the all column, right? We have gone the row, now we'll go to column. So first column, this is the first column, then this is, will go to the till the last column, and column is what, grid at 0 at row 1 dot length, till that we will go, right? And then j plus plus. Okay, you can make it row and column also I and j. So these two variables we have, right? Now what we will do, we will check we should always keep one copy of the element into grid, right, into the visited matrix, you can say, because the first time it is coming, so we'll mark it like that only. So what we will do, let me take here. So first time I'm taking I and j into the from the grid. So grid at I and grid at j, what we will have, that we will insert into our queue, right? Sorry, our grid, you can say, because one copy we have to take, right? Another, what we will do, if, so that we can compare later, we'll take if grid at this row and this column is what we have 1 means we have land, we are checking for the land, right? So if we have land means what we have to do, we have to check, we have to do q dot is remove, right? Or you can say q dot, sorry, we can add, right? Q dot offer will take, and we'll say new pair. So this new pair we have to pass I and j. So all it's now we are maintaining our queue, right? And will all the pair we will store one by one here, right? If this is done, our queue is completed. Now queue is completed. Now what we should do, once our queue is completed, we should check if queue is empty. Till that we will check one by one, we'll go up, down, we will traverse. So for that, let's suppose we'll take int the distance, right? We'll take a distance, and initial value, if we will not find the nearest, then we have to return what? -1. Correct. If we will not find the distance, then we will have to return what? -1 as output. So we will return this distance, right, as per the question, right? Now what we will do, we will check in the while if uh, the given queue is not empty. Queue is not empty, right? That we have taken. See, we have taken queue. If this queue is not empty, then it is empty. It will come. So empty. Okay, is empty will call. If not empty, till that we will go into this loop and will iterate all its you can say over the cells, right? Now what we will do, we will go for all the cell, right? Here what we should do, uh, we will take one cell, right, and we'll try to move all the directions, right? So for that what we should do, we'll take one you can say queue size. It's okay. Then we will take what? Queue size will take. Okay, queue size we have, and this queue size will take what? Queue dot size, like this. Then we will iterate over all the current cells in the queue, right? Let's suppose while if this queue underscore size we have, right? If we'll do minus minus each time, we'll do what? Minus minus, we'll reducing for each time 0. If it is greater than 0, right, then what we will do, we will take from the queue only, queue dot will do poll, and this will store what? In the pair form only, right? And this is nothing but what we will have, our integer and integer, and this is our land cell, right? Okay, now what we have, we have our land cell. Okay, once we have our land cell, then we will move to all the direction. From our current land cell, we'll traverse all the land in the 4 directions, and we'll check if it is have a water cells, then we will return yes, and we'll convert it into the land, and we will add into the queue. So for that what we have to do, we will go to all the directions, right? We'll take at a time one direction from what? We have directions, right? So at a time one direction will come and will move one by one. So what we will do, we'll take x coordinate first, and it is not nothing but our land cell, and dot we'll get key is their method, right? From the pair, for the first pair we'll get by the get key. Sorry, not get, it should be get key, that is the issue. So we will get our x first using the get key. So this is what we will doing. The pair class have a get key method and get value. So if you want to get the key, you have to do dot get key, and the direction we will use is direction at what? 0 we have. So this is for the first directions, right? This is for the first you can say uh, x, and we'll take for the y coordinate, then we will take land cell dot get value, you can say get value, and plus direction at first. Okay, all the direction at a time one direction we will move one by one, and we will check. Now what we will do, each direction we will get our x and y coordinate. Now we'll check if this x is greater than what? Greater than equal to 0. and y is what, greater than equal to 0, and we'll check if grid x dot grid, right? If x is less than grid, suppose x greater than less than grid should be, x should be less than grid length, and y should be less than its x is x coordinate should be less than its coordinate, you can say x and y columns, right? So y should be grid at 0 dot length, it should be like that, right? And then we will take the visited, right? Our visited, we have visited underscore grid we have, and at this position we have x and y coordinate, will check, and if this element is equal to 0, means we have at land. This is the reason we have taken the copy of the grid visited, right? So that grid value we have, and we will compare this one each time, because another one we are going to mark each time, right? Now enter here. Now mark as 1 to avoid reiterating, right? So we have our visited hyphen grid, right? And we'll mark this one x, y, and this is come 1. Each time we are marking, so that we will not revisit again, right? Now we have our queue we have. Then what we will do, we'll do offer, and we'll take as a new pair. New pair will come on this one, and the you can say queue, and this is nothing but our x and y. Correct? Understood? Next, if this is done, right? If this part is done, okay, so we have completed our direction, right? We have reached to this direction. But one thing you understand, that we have to increase our distance each time for this time, right? This is going for one distance, right? So we have distance. Now remember that graph, right? Now we have distance, right? So we have to do distance plus plus. Okay, we'll do distance plus plus. Since after each iteration we were creating one you can say new directions, right? We are incrementing for each direction. Each time we are completing that, we are marking, and we are saying distance is now 0 to 1 to 3 to 4, right? Like that we have done. Once this is done, right, then we will return our distance. If distance is equal to what, 0, right, then we will return -1. That is not need to do, but if not, then we will return what, our distance. Okay, so let me check once again what we have did here. First of all, we have taken 4 directions so that we can move to each direction. Then we will take the one visited grid of the copy of the grid only, and we will store all the value of the grid I and j. We will grid all the element of grid, we will put into the grid visited, and we will add all the element into element into the as a pair into the queue. Once this is done, we will have our distance in, we have initialized our distance with -1, and till the queue is not empty, we'll go and and I will take direction should not be greater than should not be less than, you can say, 0. Till that, what we will do, we'll get one land at a time, and we'll move to all its directions, all the directions, right? So what we will check, for each land cell, right, we will get at it one time, we are getting one cell at a time land, and we'll move to its all direction. So we'll get our x and y coordinate, and then we will check if x is greater than 0, y 0, grid is x should be less than its column, row and column, and then its value should be equal to 0, means we are getting water. And when we get the water, we will update our visited, that is 1, and we'll update our queue also as well as a new pair. If that is not there, means we have visited already, right? So we are actually we are marking this one as a avoid revisit. Okay, and that's all. This is the issue. So see, what I have did here wrong is we have to take 1 as a here, rest of the thing is good. Now let's submit this one. Actually x should be at the 0 and y should be at 1, right? Let's submit this one. Yeah, this is working. So thank you guys. Please continue this video so that you can understand another approach, right? So in the next part of this video we'll see the dynamic programming and we'll try to implement this one. Okay, thank you.